Hello, guys and girls. So, today we're going to talk about shaded area. And shaded area is basically one or two, sometimes three shapes on top of each other that we just have to find the areas of these given shapes and then find the region that's still shaded. So, what is most important in every one of these problems is that you locate the largest shape and then realize you are taking away the smaller shape inside. So right away, if I look at this picture, I hope you see the larger shape is a circle. Well, if I found the entire area of a circle, then I would take away the area of the square that's inside that circle. So the first thing I'm given, as you can see, is 16 feet. Well, what is 16 feet? It is the radius, the diameter of the circle, and it's the diagonal of the square. So the first thing, if I was going to find the area of the largest shape here, I would want the area of a circle, which is pi r squared. So I already know that pi, and then the radius I know is 8. So you're going to get pi times 8 squared, which is 200.96. The next thing I'm going to do is find the area of the square. Well, what you have to realize is that I give you the diagonal of the square, which means this side's x and this side's x. So you have an option of doing x squared plus x squared equals 16 squared and finding out what x is. Or I'm going to do leg times root 2 equals 16. Since I know it's a square, I'm going to divide by root 2. I'm going to get x equals 16 over the square root of 2. I'm going to rationalize the denominator. I'm going to get 16 square root of 2 over 2. I'm going to get 8 the square root of 2. Now, you could have done Pythagorean theorem if you're faster at Pythagorean theorem. The next thing I'm going to do is take this side now is 8 the square root of 2. And this side's 8 the square root of 2. So I'm going to find the area of the square, which is 8 the square root of 2 times 8 the square root of 2. That's 64 times 2, because square root of 2 times square root of 2 is square root of 4, which is 2, which is 128. Now that I have these two areas, my final result is going to be to take 200.96, the larger area, minus the smaller area, which comes out to be 72.96. Let's use some number literacy. Can I obviously get a negative number if I'm talking about area? No. Also, the second thing is it is area, so it should technically be feet squared. Okay, that's what every one of these problems is basically going to do, is talk about the larger shape, subtracting out the smaller shape depending on what we have. So let's take a look at the second one. If you take a second and analyze this circle, you'll see you have a large shape. Well, what is the large shape? It's almost a circle. It's half of a large circle. Well, what is the radius of the large circle? So hopefully you realize the radius of the large circle, which is from here over, is 4. So the area of my circle is going to be 4 squared times pi. But what am I going to do with that? 50.24. But that's if that was the whole circle. This is only half of a circle. So 50.24 divided by 2 is 25/12. Okay? What I need to subtract from half of this semicircle is 2 small circles. Well, if it's 2 small circles, what is that? That's 1 circle. So when I do this next circle, do I really need to use the half formula? No. All I need to do is find the area of one circle, since it's 2 halves, with a radius of 2. So 2 squared is 1256. And then I'm going to subtract these. And 2512 minus 1256 is 1256, obviously. And its area, so it's centimeters squared. So this next problem, which I call a bullseye problem, is one of the most complex problems. But if you can kind of get an understanding of what a bullseye is, it's not such a bad problem. If I look at this bullseye, the largest shape in this bullseye is a circle. So let's say the outside of this circle, trying to change the lines out. Okay. Let's say the outside of this circle was shaded. Okay, so everything on here would be shaded. Everything on here, if this was a large circle. Well, what a bullseye does is then take the first ring here and erase it. That's how it makes an outer edge. But to make a new shaded piece, it then has to take a color and color back in to make this new shaded ring. It would color it back in, and then what it would do is take this piece and erase to get the center. So if you can understand that a little bit, you would understand that to make a bullseye, we're going to start with the largest circle in the problem. So I'm showing you that each tick marks 4. So if each tick mark 4, the radius of the largest circle from here over is 4. So I am going to take the area of the largest circle, which is 4 squared pi, which is 50.24. Then I'm going to find the area of the circle from here to here, this circle, the first white circle. So that is 3 of these. So that's 3 pi squared. And that is 28.26. But if you remember, it's an entire circle colored in with minus this. So the first thing I'm going to do is subtract these, and we can do it all at the end. But to get this gray circle again, it's coloring back in. So when I find the area of this circle here, it's a radius of 2, which is 2 squared pi. 4 times 3.14 is that 1256. I'm adding that back in, and to get the white part, I'm then subtracting 1 squared pi, which is 3.14. So to get my final answer, I'm taking 5024, subtracting 2826, adding back in 1256, and then subtracting out 3.14. And if you take a second and do that, you should end up with 31.4. Now I could double check. 50.24 minus 2826 plus 15 minus 3.14. 31.4. So that is the shaded area in meters squared of what's left in the shaded region. Please pause the video. Try this one solely on your own before you look at my work. Please look at the picture, analyze what the radius is of the larger circle, subtract out the radius of the smaller circle, since it's only basically a donut instead of a bullseye. Hopefully you paused the video and now you're coming back, and hopefully you realize 4 squared pi is the area of the large circle, which is simply 5024. And then you are subtracting out the smaller circle, which is 2 squared pi, which is that 1256, and you're subtracting these to get 3768. And that's the area of my small one. That's the area of my shaded region, the outside or the donut. Let's take an area of this one. Okay, so let's look at this last one, and hopefully you realize my larger dark shape is a circle. It's a full circle. And since AB is the diameter, you can see that from here, the center this dot all the way over, I guess different color, from here over is 6, so my radius of my circle is 6. So if I want to start with the largest shape, which is a circle, it's 36 pi, because 6 squared is 36, and 36 pi runs at 113.04. Then what's the shape inside? So hopefully you realize it's a trapezoid. So if I'm finding the area of the trapezoid, then I'm going to take 1/2 the height, base 1 plus base 2. And how am I going to know these? You're not, but you're going to have your formula sheet, so you would be fine. And if you realize this, 1/2 the height is 4. The base 1's the top, which is 3, and the base 2, you got to be careful. You don't have this piece, but from here to here is a radius. And if the radius is 6 of the circle, this is 6, so this is 12. So 2 times 15 is 30. Area of the circle, 113 minus 30 is 8304 centimeters square. Let's look at our last one. Go ahead and try this on your own. Hopefully you take a look, and the larger shape, I see my corner's 90, so I know it's a square given that each side's 10 and the corner's 90.